Hello, hello, sound. Oh, wait, let me turn on the lights. Mm-mm. Sound testing, testing. All right, how about now? Sound testing, testing. Yeah, I wasn't recording. Good afternoon, everyone. How's everyone doing? Okay, sorry, I'm a little late. I was kind of tired after this morning, so I decided to just take an extra 30 minutes, run an errand, and come back. And I am also brewing some coffee right now because I think I'm gonna need it this afternoon. How's everyone doing? Who's here? Do I know anyone on the chat? Feel free to say hi. If if you've been here, if you're part of the community, just say hi. If you're new, remember we have a where is this? We have a yes, we have a Discord channel that you can join, and where we have offline conversations during the week. We have chats, we help each other. I sometimes ask for suggestions about topics um, for live streams, for tutorials. Hey, Kiran, good to see you. How are you doing? Okay. And Kiran was very naughty this morning. While I was doing my thing, he was connecting to my servers and sending information. It was a lot of fun. Simon, good to see you. How are you doing, sir? Okie dokie. So, what are we doing today? This afternoon. So, this afternoon is going to be more of a work session rather than a tutorial per se, because what I would like to do is I would like to continue with the WebSocket series. And this morning we did Telegram bots, which I see as probably something for the end of the playlist. But last week we recorded a bunch of tutorials where we discussed how to create a WebSocket server, put it online, etc., and connect with a client. And the clients that we used to connect were mostly JavaScript based. So they were P5 JS sketches, or they were Node applications themselves. So I would like next week to record more tutorials where we connect different clients from different environments to this WebSocket server. I would like to do Python, because but I would also like to do processing. I would like to do Grasshopper, and I would probably like to do Unity if we have time for that. Now the problem is Glitch has a special security feature that requires that WebSocket clients, the WebSocket clients have these special headers identifying them as what kind of agents they are. And typically, that is not a very normal thing. So typically, libraries that do WebSocket communication, they don't really let clients do that. So that requires some special configuration. And the most common libraries that I have seen for processing and for Grasshopper, they do not come with that. So what I would like to do today, this afternoon, is to start with Grasshopper and see if I can manage to put together a WebSocket client that we can use to communicate with the server in real time, but it incorporates this user agent identification. My plan is to base myself on some open source code that I have found online, and I think what I would like to do is I would like to try first if it works, and if it doesn't, I would like to try to change things around so that we can make it work. So very likely, the first part of this work session is going to be just trying out if the Grasshopper workflow works. And if it doesn't, then it will become a hands-on workshop on how to take somebody else's Grasshopper plugin, start a development environment, change it, and then hopefully compile it with the changes that we want. So the workshop is going to be very much around taking someone's code for a Grasshopper plugin, customizing it and creating our own version of that plugin, which I think has quite some interest. I hope to make it in a way that we can cut it and edit into a video that is a more formal tutorial, but if not, I would be okay for that. I would like to make this more of a work session, an experimental session or something like that. I have some coffee brewing, so let me just go get it and I'll be right back. Hold on. Yes. So as I was saying, and if you're interested in following up with this work session, I think this could be really useful if you want to learn things such as really customizing some of the properties of WebSocket clients, and especially if you want to get a sense of what going into GitHub, pulling someone's code, installing it into your system, compiling a Grasshopper definition, making modifications, a development environment, debugging, and those kind of things. So it's more like a let's see how Jose deals with this with this situation, and maybe you can learn some out of the headaches of my experience or something like that. Okay, so yes, so that is what I think I would like to do. Any comments? Hey, Salvador. Good afternoon. Any comments, suggestions, things you would like to do differently? I don't know, or things that things that you would like me to focus. I would like to do this a bit more interactively. So because it's going to be more of a work session, if anything that I do doesn't ring a bell, or you're like, wait, where the hell did that come from? Or why is he doing that? Feel free to just put it in the chat and I'll be happy to explain a bit more in detail some of the things that I might be doing. So I think the first thing that I'm going to do is I'm going to try the workflow that I think is not going to work. And if it doesn't work, then I think I will switch more into a let's modify a Grasshopper plugin kind of video, and maybe we can actually turn that into a video, like a longer session, like a longer tutorial. Yes, so we're going to do that. Let's get ready for this. It's kind of sad. I typically listen to very upbeat electronic music when I'm coding myself. I don't know how you do that yourselves, but I don't think I can do that while I'm on the live stream, right? I don't know. Okay, so let's start. So what we're going to do is we're going to try the workflow that hey Parastorm, a long time no see. How are you doing? Stan, good to see you. So we're going to try the workflow that I think is not going to work. And if it works, then we're done. If it doesn't, then we record a video. So I'm going to open Rhino 6, for example. I have 6 and 7 right now on my system. And I'm going to open Grasshopper. I'm going to see if I have the plugin that I wanted. So yeah, I don't really have it because I actually just installed. I'm using a fresh Windows that I reinstalled this last weekend. So I barely have anything on my system right now, which is kind of nice. So what I'm going to do is I'm going to download this plugin because it has WebSocket communication. And where is the GitHub repo? Because it's open source. Yes, Venge on GitHub. Okay, so Venge is a Grasshopper plugin by a friend of mine, Bruce, that he studied the iTech at ICD. I met him at a conference. Really nice guy, very, very smart. So he made a plugin that has a bunch of things such as HTTP server, clients, WebSockets, etc. It's kind of nice. It's like a mixed bag of a lot of different things, but it's open source, which is not very common in the Grasshopper community. So I very much appreciate that. So we're going to download. First, we're just going to download the plugin from out of the box, so just as it is, and then I'm going to install it, see if it does what I want to do, which my belief is that it will not. And then so I'm going to open the components folder, and I have nothing. I have no plugins. Can you see? Can you believe that? I have absolutely no plugins, which is great because again, I just install. Okay, so I'm going to extract this here, and I'm going to check that it's not blocked, which is not, so that's going to work. So I'm just going to restart my Rhino and my Grasshopper. Okay, and I should have Venge right here. Venge has a WebSocket client, starter, a sender, and a receiver, which is great because we're going to connect to the Echo WebSocket server that I made a while ago. So the WebSocket server is this one, and I forget. So what was the? Yeah, so this was the URL. So the URL is going to be this one here. Oh no! Oh God! And it's okay. So let me change this. I cannot do this. For the love of me, I need white. Yes, exactly. Color and then a little bit transparent. Like a tiny bit of transparency. Yes. URL. Oh, because it needs to be a WebSocket server. You're right. So I'm going to do WebSocket here, connecting. Am I connected? Hello world. Restart the connection. Message content. No. Update automatically. Oh no. Sorry. Let's make this the default color. Actually, let's make it absolutely opaque. Okay, so we have that. And then, oh, and let me just drop in. Oh, I don't have it. Okay, so let me download bifocals because it's because I know many of you don't like icons. So let me do oh, what am I in Rhino events? Bifocals. Really nice plugin by Mark Sip, also a friend. I'm gonna put it in the desktop, and then here bifocals. Just gonna drop it in here, and I'm going to unblock it. And I may need to restart actually for that to work, but it doesn't matter. So let's see if this is working. So I get this. Okay. Hello world status is a message. Auto update boolean toggle. So we are. I'm just gonna yes. So auto update. This is sending to them. Well, so actually this is working. Is this working? So it is working, actually. Interesting. So maybe... Okay, so let's connect something else, see if it still works. So, for example, because it's auto-updating and it's listening, so perhaps if I connect with the editor, with one of the bouncing chasing balls, I should... Where is the server? So the server, what is the status? Received message from client, a client just connected, hello world. So what if I do this? Oh, I just connected to the server. Okay, I just connected to the server, pcam. Oh, it's because we're on different servers. And this is an echo server. So, okay, so let me connect to the other server. Because right now they are on different servers, so that's why it's not working. To the echo server. Oh, why did this close? And, all right, so this closed. Okay, so button, let me reset the connection. Okay, so, okay, hello world. Oh, so it's actually working. Oh, it is working. So I am receiving. So let me see if I can send stuff. So I'm going to send a message. The message is going to be, I'm going to copy this and I'm going to send a message where I'm going to send a hard-coded JSON object that is going to send the ball to the middle. That's going to be 0.5 and 0.5. And I'm going to connect that. And then I'm going to poop. Ah, so it worked. So this thing doesn't have the limitation for amazing Venge. I like it. Very nice. I wonder if the component already has that. So let's take a look. WebSocket client, WebSocket start. Let's look at the code, the address, and it's using Venge WebSocket client. New WebSocket. Okay. WebSocket object. Oh, okay. Well, so this is very nice. So I stand corrected. This is not needed. Okay, so maybe we can, okay, let me play with this a little bit. So we do this, so this is going to be X and this is going to be Y and this is going to be Y, and then what we're going to do is we're going to create now a component that stringifies this. So we could actually use JSON, but let's do it just manually. So we're going to concatenate a bunch of strings. So that's one is going to be, the first one is going to be this. So we're going to concatenate the first part of the JSON object, which is going to be this, and then we're going to concatenate the second part, which is going to be everything in the middle, this part here, and then we're going to attach the value, and then we're going to attach the last part, which is the closing curly. the closing curly, which is this one here. And then we're going to do this. And then now look, I'm going to do 0.2, boop, 0.3, boop, 0.7, 0. I don't know. Woo! Oh wait, then I know. Why don't we do? There's a 2D slider, right? Yes. So what do we get out of this actually? Oh, this is going to be nice. Okay. So I guess what we need here, because it's a vector that we're getting out. So deconstruct point into XYZ, and then we plug this in here. We plug this in here, and then whoa! Whoa, that's cool. Yay! Well, that was very fun, actually. That was a lot of fun. Okay, that was very nice. Okay, and it's very responsive too, which is very nice. Well, that's great. I wonder if we can now. I wonder if we can make it now the opposite. Can you make it follow a polyline? Yes, we could. We could just well, let's do that. Let's make it follow a polyline. So I'm going to enter a polyline here. The polyline is going to be well, one thing I'm going to do so that it's not confusing is that I'm going to negate the y-axis so that, because, oh, wait, no, that doesn't work. Oops. Nope, that doesn't work. Okay, so because you see I'm moving up and it's going up and I'm moving down. So I guess I need to do here an expression which is 1 minus. So I need here to do, yeah, I'm just going to do 1 minus x, 1 minus y, and so that we actually have the right coordinates. Okay, so that, yeah, now it's, because remember P5, that's positive x and positive y is pointing down, whereas in Rhino, positive x is pointing up. This is pretty fun. Okay, and this is very smooth actually. So how can we make it follow a polyline? Well, first of all, let me do the other way around. Let me do something where I use this, because now we can receive messages. You see? So let me do something where I use this screen to control the position of a circle or something like that in here. So let me just save this to some test, like WebSocket Grasshopper test, for example. And what I'm going to do is, so I'm just gonna, I only need to just take this and parse it, which for that I'm really gonna use JSON because it's amazing. So JSON, it's also open source, by the way. Very good stuff. No, download it. Let's download it here. And I'm gonna put it on my, I thought I had a link to here. I'm going to do JSON, put it here, unblock it. So I'm going to restart Grasshopper. Okay. And then I'm going to open the test, and then here on the message, here I'm just not, I don't want to send a hello message. I'm just going to send an empty string. Yes, because who cares about that? And then here on JSON, I'm going to deserialize this JSON into X and Y. I'm actually going to, well, that's fine. I'm going to do that as well. Anyway, X and Y, and then I can just use that for the position of a circle. With Y, I'm also going to invert it so that it's in the same coordinate space, and then an XY plane, construct a point. I'm going to construct a point. I'm going to construct a point here, and I'm going to drop the bifocals now that I have restarted. There you go. I'm going to construct a point here. This is the X and Y plane. And then I'm going to just drop a circle here. And the circle is going to be small radius so that it's, the size is not competing. Okay. And I think this should work, right? Because now if I change this, I'm going to minimize Grasshopper. I'm going to turn off the preview of the plane. This plane and this plane. And I'm going to make a surface so that it's a bit clearer. Surface, planar surface. Okay. All right. And so you see the circle there. And then you see how, if I move it, you see how it's going to 0, 0, 1, 0, 0, 0, and 0, 0. So we don't get the nice animation part because, you know, it's Grasshopper. It's a bit more difficult to animate stuff, but I mean, we could really. Shall we do it? Let's animate the circle. Okay, so for example, we construct this into a point, okay? And then I'm going to create a C# component here. And I'm going to do point 3D. And it's going to be center, for example. And we're going to apply the same logic that we have here. We're just going to ease the circle into we're just going to ease the circle into the target position. Okay. So the circle is going to be this one. Radius is going to be a float, a double. Center is going to be a point. We got it already. So I'm going to plug this in here. I'm going to plug this in here as well. That was a very useless slider. Plug this in here, and then we're just going to do this with C#, I think. Okay, so how are we going to do this? Well, what we're going to do, I think I've covered this in some of my previous tutorials, is what we're going to do is I'm just going to create a point 3D object here, which is going to be the target. All right, and then every time and another one. Well, I'm going to call it just like we have it here. What do we have? We have position and we have target. So here I'm going to do point 3D, position, and target. And now every time something changes, I'm going to say, every time I get a new center, I'm going to say the target is going to be whatever the center that has been given to this component. And then every time I update, what I would like is to make the position a bit closer. Oh, I'm going to add easing speed here. What I would like to do is every time easing is going to be, for example, what value were we doing here? Easing speed 0.05. Okay, so I'm going to copy this and it's going to be 0.05. Easing is a double value. So what we're doing here now is, oh, I didn't save. All right, sorry. Well, point 3D position, point 3D target. Okay, and let's start simple. Every time target, every time something changes, the center changes, we're just going to say that that is the target. Okay, and what we're going to do is we're going to create a circle that is going to be placed on the target, or we're not going to ease it so far. So what we're going to do is we're going to create a plane that is going to be equal to a new plane on, which is going to be equal to a new plane origin. So origin is going to be target, and x direction is going to be vector, like a global x direction, and then vector 3D global y direction. Okay, and then a circle C is going to be equal to a new circle of radius, and the plane is going to be DL. Radius, and then the outcome circle is going to be C. Let's see if this works. So I'm going to put this, make like a tiny window here, so that I can see some values here. Okay, and then, okay, I'm just going to do this manually. So I'm going to, okay, and then, why is this not working? The field, so who cares? It doesn't matter. Center is this. Okay. So maybe, are we still connected? No, we disconnected for some reason. Okay, so we're going to connect, and then, are we still connected? Double click to edit panel content. We are not connected, so let me reconnect here. Okay, so it looks like the communication dropped for some reason. So, but now it's good. We're back where we started. And then here, what I would like now is to ease this. So what I would like to do is, okay, so instead of speeding the circle exactly on the target, which is given by the center that is changing every time we receive new data from the WebSocket server, what I would like to do is I would like to use position. But what I would like to do is every frame, just like we were doing here, I would like to update position, the x coordinate of position to be the value of easing times where the target is x minus where the position x is. And then position y is going to be easing times target dot y minus position dot y. And this is going to work because since I put this data here, this data is going to be permanent. is going to be persistent. This data is going to be persistent across solutions. So whenever the solution changes, this data is not going to be removed. And that's why it's interesting. And this is a capital Y should be here. I think this is working, okay? But now you see that I changed things and this is moving very, very painfully, taken slowly. It's not really doing what it should. This is because this component here is only updating. Oh, you can see it really. This component is only updating when, let me actually move this here. This component here is only updating every time. Oh, this is weird. This component is in times, because we need to plus equals. Yes, there you go. You see, this component only updates whenever there is an input that is changing. So what we need to do is we need to force this change, and we need to do that by applying an interval. So for example, a timer every 50 milliseconds, and then now 50 milliseconds is really bad. But you can see, oh, this is fun. Okay, does window size come into play in Rhinospace? If you mean the size of this window, it does not. Because in Rhinospace, we're just using the range of 0 to 1 as absolute coordinates. We're not using it as relative coordinates. If we were to say, oh, I have a rectangle and the rectangle is like whatever size. Actually, so for example, wait, that's an interesting. So let's see. Let's imagine we had a surface. I'm going to create a surface. So for example, let me create a surface. Why is this window weird? Let me create a surface, and the surface is going to be something like that. And the surface is going to be something like that. And I'm going to, I'm doing it in the front. Wait. Let me do it on the right. So surface is going to be something like this and something like this. And I've done it in the front again. Okay, and then I'm going to move it here, and I'm going to loft them. I'm going to loft them, and I'm going to align the curves. Why is this? God. Okay. I'm going to flip this. So now I'm going to loft the surface. Okay, much better now. I'm going to have this here, and I'm going to bring the surface into I'm going to bring the surface in here. Set one surface. So the surface is basically now a NURBS space that has a domain that goes from 0 to 1 in some random direction. So I have the surface here, and because the surface has the internal two directions, the U and the V, those may have a range from 0 to some value, but what I can do is I can reparameterize the surface. So for example, I can say evaluate surface. Where is evaluate surface? Evaluate surface. I'm going to take this surface and I'm going to say, give me a value here, this one. Give me a value from 0 to 1. You see? So it looks like this surface is all the way on this corner. I'm going to flip the surface just so that we have, yeah. So if I reparameterize this, you can see that now 1, 1 is all the way in this corner, 0, 0. And it's just the surface is not really matching the orientation of this thing. So I wonder, can we flip a surface? The direction of one object. So maybe what I can do is I can just flip both curves. I can just generate the loft from this curve to this curve, and maybe that will generate a different internal orientation. Yes, it does. So 0, 0 is now more aligned to the window rather than... Okay, so now we have this surface here. And what we could do is we could use the surface as a two-dimensional space that has values from 0 to 1, and therefore create, for example, create a sphere that is moving, that is animated over this surface, and the direction is coming from the WebSocket other client. So something we can do, for example, is I can take this center, I can take the surface, for example. I can take the surface here. Let me keep this one as it was, and let me just copy a similar one here. I'm going to take the surface. All right, I'm going to take this surface here. I'm going to make it a surface object. Then this is going to be a sphere. And then I'm not going to need any boundary surface because it's already going to be a sphere. The easing and the radius are going to be whatever. And then I don't need this because that's the data that we're getting from the center, and this is the surface. And then in the code, what I'm going to do is I'm going to say target position X, position Y. And then basically what I'm going to do is I'm going to say, I'm going to find a point on the surface, which is going to be surface, and then point at in coordinates U and V. And that's going to be position X, and that's going to be position Y, because remember, position X and Y are normalized. So our values from 0 to 1. And actually, I think I may have to reparameterize this surface. I don't know. But then with that point on surface, I can just say sphere S is going to be equal to a new sphere on position and with radius. And then I can just output that as sphere equals S. And I'm going to do that. And do I see the sphere? The radius is very small. So I'm just going to paste here. Okay, so I'm getting... Oh, because I need to use point on surface, not position, sorry. There you go. And now, are we connected? No, we're not connected. Connecting. Message. And then let me reconnect here as well. Just so that okay. All right, so this is working. And then is the sphere actually moving at all? Let me check. It's moving a little bit, but it's not moving all around the surface because the surface has probably a domain from... So let me actually check the domain of the surface. Deconstruct domain. So the surface goes from 0 to 23 in one direction and from 0 to 38 in the other direction. This is the same problem as when we had this sketch in pixel coordinates instead of on normalized coordinates. So we can just either reparameterize the surface, reparameter, or we can probably just do that inside of the component. So I forget how that was, but probably we can do surface dot re or we can just set the domain. So surface set domain in the direction 0, and it's going to be a new interval from 0 to 1, and then in the other direction, in direction 1, is also going to be from 0 to 1. So is that going to work? I don't know. Doesn't seem to be working. Huh. So here I am sending values from almost, they are almost at 1, but the surface is not really. Oh, that sucks. Oh, because I don't have the timer. Silly me. All right. So wait. Ooh. Yay. We're navigating the surface. Boo. Boom. Poo. Okay, this is fun. I love anything that is WebSocket based and real-time interaction and that kind of stuff. Okay. So you can see how the surface has now. We can stretch this, for instance. So we can just move all of these points, for example, like this. So you can see how we can go all the way up to this corner, and then this corner, and then this corner, and this corner, and the center, and this corner here, this corner. And look how interesting this is. So you see how I stretch the surface and how basically there's a lot of control points here and a very large gap without control points, and then all these points at the end. And that's why these ISO curves are centered. The center of them, the crossing is like offset. If I move the point to roughly the center of the screen, you can see how the ball doesn't really go to the center of the surface, which looks like it would be somewhere here. It goes to the center of the parameter space of the surface. Oh, it goes to the center of the parameter space of the surface, which is roughly around here. It's not there, so which is kind of nice. And also you could see how, yeah. Okay, this is we're totally going to use this for our next few exercises for the playlist next week. Okay, so what else? Oliver, he wanted to follow a polyline, so we can do that. How can we do that? So we probably want to make the sketch on the left follow a polyline that we draw on Grasshopper, on Rhino. So we can do that. So for example, I'm going to draw a polyline. The polyline is going to be this. I'm going to do it more quickly. You see the sound effects? Okay, so this is going to be the polyline, for example. And what else? This is going to be the polyline. Mm-hmm. Mm-hmm. Okay. I know the kind of problems we're going to run into. Oops. So how are we going to do that? So we're going to need to define some kind of boundary, which is going to be like the canvas, so that we can create for each one of these points, we can find normalized coordinates. Okay, let me run into the problem, and then when we hit the problem, we will see how to solve it. So let's see, for example, remember that one of the main problems that we have, or the advantages, or the things, how we set this up basically, was that we decided to work in relative coordinates so that whenever we had environments that had different screen sizes or canvas sizes or spaces, then we always work relative to a boundary condition. So remember that we were always exchanging x and y coordinates that were from 0 to 1. And then we mapped those 0 to 1s to whatever space we were working on. That's why, for example, we did this here with the perspective. It's a little late. We did this with the surface. The surface has whatever size in x, y. But in parameter space, we have reparameterized this so that internally the u direction goes from 0 to 1, and the v direction goes from 0 to 1 as well. And that's why we can, and it looks like they're disconnected again. Okay. So yes, Kiran, we're gonna have to do something like that, like a bounding box and then reparameterize. So let's start by doing it. So where is Grasshopper? Grasshopper is here. So let me take the polyline. Should I start a new sketch? I'm going to do test number 2. And for this one, we're going to do sending rather than receiving. We're going to keep this listening, but we're going to remove all of this. And I'm going to connect here. So what we need to do, we're just going to keep this to listen just for as a debugging tool. But mostly what we need to do is we need to figure out first how to read the polyline, how to split it into different vertices, then how to send normalized coordinates for each vertex to the WebSocket server, and do that on a loop of sorts. So let's start by taking the polyline. The polyline, let's take it the curve, which is going to be this polyline. It's a polyline curve. So do we have polylines here? No. So let's take the let's extract the vertices of the polyline. So how do we do that? How do we extract the vertices of a polyline? Control points, I guess. We can get the control points, yeah. And so there we get all the vertices. And then with the control points, what I'm going to do is, now that I have a list of control points, what I would like to do is I would like to write something that goes over this list, and every second it sends the first object, the second object, the third object, the fourth object, and so on in a loop. And then when it hits the last one, it wraps up. So for that, first of all is I'm going to need to write something that I'm going to need to list the item, for example. List this item here, okay? And I'm going to say Let's do this manually first, and then we write an automated tool. So for example, let's say we have a slider that says pickup number 0. So this becomes this point, which is the first on the list. And then as we do that, I'm going to want to decompose this into XY and plug these XY coordinates into here. Okay, X and Y. And I'm going to do the -1 here as well. Okay. This is not going to work because, are we connected? Yes. So you see, this is not going to work because you see here I am receiving coordinates that are larger than 1. So that's why the ball is just going somewhere haywire, somewhere crazy. So what we're going to do is we need to take each one of these. We need to take each one of these points, and we need to figure out a boundary condition like a bounding box or a plane or whatever, and we need to find the relative position of each one of these points in that rectangle that is the bounding box. So how are we going to do that? I mean, this is basic Grasshopper, which probably many of you are better than me at this point, because I've totally lost boundary surfaces. No, I want to create a boundary. I'm taking suggestions. If you think of a nice, elegant way of doing this, because the one that I can think of is a little convoluted. So if we do bounding box, of these planes, then we get this. No, I don't know. I want a union box, so I get this, which is a box. It's not really a plane. Flat box, and then I can get, for example, the construct box, which is going to give me the plane. What is the plane of the box? The X dimension, the Y dimension, and the Z dimension. That I can use to remap stuff. You can also do bounding rectangle for 2D surface. How do I do that? What is the bounding rectangle for a 2D surface? Is that bounding rectangle? How do you do the bounding rectangle for a 2D surface, Oliver? And where is this plane? World X and Y? Yeah, that's not what I want. I want box corners. But actually, you know what? Actually, this is good enough, because if I have the domain and it tells me I can take all the X coordinates and remap them from the original domain to 0 and 1, and all the Y coordinates and remap them from. I think that's going to be nice. Okay, so let's remap this. So it's just, we're going to do like a simple numerical rule, which is we're going to remap those numbers. Let me deconstruct. Okay, so we're going to take. Should we just do it for all the points? Let's just do it for all the points, and then we cherry pick the ones that we want. Okay, so we're going to take all these points. We're going to deconstruct them. Okay, and now I'm going to take all the X coordinates. All right, and then the X coordinates, the source domain is going to be the one that is given by the bounding box, and the target domain is going to be 0 to 1. And therefore, I get a nice list of all the X coordinates remapped from to 0 and 1. That I find clean and elegant. and then we're going to do the same with y, and then we also get a set of 0 to 1s, and then we can reconstruct those into points. I mean, construct points. We can construct these x and y, and now we plug this in here, and now we have values from 0 to 1. And let's see if this works. So let's reconnect and connect this guy again. And so let's send number 1. Oh, wait, this is working? Okay, so let's constrain this here. And so we had this, okay? And we are sending number 1, which is this one. And then number 1 should be this should be number 2, number 3, number 4, 5, 6, and then 6, I think we're here, 7, 8, 9, 10. Woohoo! It works. Okay. Right. So if we keep going, for example, here, so we can just say I'm going to do 11 and 12 and 13 and 14 and 15 and 16, 20, 21. So yeah, 20 is this one. 21 is the one right above. 22, 23, and 24. So 22, 23, and 24. Okay, so you can see that the stelae here, I don't know if you can see it, but it kind of follows this. So that's nice. And then now the only thing we need to do is we need to figure out a way of we need to figure out a way of doing this on a timer. And actually, you know what? What I'm going to do is I'm also going to pick up the original points with the same number so that when we send something, we can see which target is the one that we're actually sending. You see? 1, 2, 3, 4, blah, up, blah. Okay, so that looks good. And so now you see we're here. This is the value that I'm using to decide which point is the one that should be sent as a target for the ball to chase. Which means what I'm going to do is, the only thing that I need to do is I need to write something that every second, something that starts with number 0, and every second it increments by 1, 2, 3, 4, 5, 6, and plug that in, and then that gets sent to the other client. I think Firefly has a counter that just updates and changes the number every so often. I'm writing a plugin called Data Tools in Grasshopper that also has a counter and a clock. I wonder, do we have a clock here? I wonder if, I guess you have to, well, I mean, it doesn't matter. We can also do it manually. It's actually quite simple. So for example, the way we're going to do this is I'm going to write a C# component, and I'm going to add an input here called reset in case I want to start from scratch. And then that's going to be a Boolean value, and I'm going to add here a toggle. All right, and then here I'm just going to create a persistent variable called value, which is going to start at 0, the first time it initializes. And then whenever this component gets updated, then what we're going to do is we're going to say value has to be equal to true. Then what I would like to do is I would like to set the value to 0. Otherwise, I would like value to be incremented by 1 unit. And the output is going to be, counter is going to be equal to this value. So I'm going to rename this counter, okay? And let's see if this works. So what I'm going to do now is this is at the value of 1. So I'm going to put here a trigger or a timer, okay? And I'm going to connect this here. And you see, now every second, this component gets updated and this value updates by 1 unit. And then when I hit the button here for a reset, it goes from 0 to 1. Okay, so now, are you ready for this? Oh ho ho! And we are disconnected. Damn it! Okay, so let's connect again. And then let's connect this. Yoo-hoo! Air control, air control. We are, with Grasshopper, dynamically controlling the geometry or the animation of an animated sketch that is living somewhere on a website. How cool is this? Let me actually try to open up the other sketch, the one that was not really on. I had here simple WebSocket server. I had another project that was, you see, I'm receiving stuff from the client. I had another project that was the same P5 sketch, but it was just, yeah, so this one here. I wonder where is this connected to? Yeah, this one is not working because we want to connect to the simple WebSocket server. There you go. There you go. I'm really bored, as you can tell. I am not. I'm actually quite excited about this. All right. How was that? That was fun. Okay, so what's going on here? Why did this stop working? Huh. Well, I don't know why. I wonder if this I wonder if glitch has a problem with oh, maybe this got disconnected. Yeah. I wonder why Venge disconnects. Mm-hmm. Okay, so remember how I started the live stream saying, "Oh, I think I'm gonna run into an error." So it's going to be we're going to be hacking somebody else's plugin. Well, it turns out the plugin was working great, and I didn't know. So because I know I've run into this problem on processing, for example, with the library that I was using in processing. So I mean, this is great. Bengesh, big thumbs up for the work. and I think this was a little all over the place, but I think what I would like is Salvador's fault. So I think what I'm going to do is I'm going to save these examples, and then next week, when I extend the WebSocket client library, the WebSocket examples on the playlist, and I extend it to Grasshopper, I think I'm just going to use some of these examples, and then I will record the video a bit more formally than this experiment that we just did today. Okay, so this is working. I wonder if the client has some kind of timeout that makes it close automatically. Okay, so I think with this, it's Friday night here in Cambridge, so I think I'm gonna call it a day. This was way more successful than I expected, so that's great. I think I have some time to do some Q&A questions, social, whatever folks are interested in doing. So, do you have any questions? Any topic you want to talk about? What do you think? What are you thinking? I can spend an extra 5 minutes around here. Let me copy paste a few files. Okay. What am I doing? I'm saving the files so that I don't lose them. Okay, so fine. Okay, well, if there aren't more questions, I guess I'll see you. Yes, Said, you can ask. You can ask whatever you want. Please go ahead. Robotic and AIs and real-time stuff. Yep, that is exactly the kind of things that I like doing. Very good. Oh, I see Paola is introducing herself. Hi, welcome. I don't know if you're in the chat right now, but it's a pleasure to meet you. And from Mexico. Oh, we have a lot of people from Mexico. Good to see you. Hey, Paola. Hi. Thanks for introducing yourself. All right. So, okie dokie. Well, yes, I think I'm a little brain dead at this point. So I was not being very eloquent. So I'm just going to call it a day. I kind of like this model though. The model of in the morning recording real tutorials because my mind is a little more fresh, and then in the afternoon doing perhaps more like an experiment, see things work out, and if it doesn't, and prepare stuff for the week after. I may do that again at some point. Wonderful. Thank you very much. It was a pleasure to spend the afternoon with you as usual. Thanks to all the familiar faces, and I will see you Friday next week, probably. Stay tuned on Discord, stay tuned the Google Calendar, stay tuned on Instagram, Twitter, etc. We announce when we go live. And if you like what you saw, consider subscribing, consider liking this video, consider hitting notifications, all those YouTube things that we do these days. Okay? Thanks a lot. Happy to see you. Have a good weekend. Bye bye.